Alright guys, it says here, hi boys and girls, this week I have prepared a test for you. Take time to do it well and check your answers with your teacher. Select the response for each item. Number 1, in the number 676, the 6 in the hundred place is dash the value of the 6 in the ones place. All right, so here we have the number, and here we have this 6, and we have another 6 here, and we're saying that the 6 in the hundreds place, this one, how much greater is that one in value than the ones place? So is it 10 times? Is it 100 times? Is it 1,000 times? Is it 1 time? So what we'd have to do, look at this 6 here, and then we say, all right, if this is 6 times 1 to get 6, but this is what, 6 times 100. Can't be 10 times, because 6 times 10 is 60. 6 times 1,000 is 6,000. 6 times 1 is 6. So thus common sense, it would be 6 times 100. So it's 100 times the value of the 6 in the ones place. Number 2, in the number 457,514, the 4 in the 100,000 place is dash the value of the 4 in the ones place. So here we have that one. So we have that 4 here, this 4, and this 4. What's the difference in value? So again, this is in the ones place. This would be times 1, but this is times 100,000, right? So our answer for this one, would it be 10 times, 1,000 times, 10,000 times, or 100,000 times? It would be 100,000 times. Number 3, what is the digit in the 100,000 place in the number 9,862,754? What's the value of the 8? Okay, so let's identify where the 8 would be. So here we have the 8. So if we're going this way from right to left, we have our ones, 4 in the ones place, we have 5 in the tens place, 7 in the hundreds place, 2 in the thousands place, 6 would be in the 10,000s place, and 8 would be in the 100,000 place, and 9 would be what? In the millions place. So the 8 here represents 800,000 in this particular case. All right, let's go to number 4. What is the place value of the 7 in the number 3,472,819? And here we have that one. So what's the value of this? So we have 9 ones, a set of 10, we have 800, we have 2,000, and we have what? 7 sets of 10,000. So the options that they have here are tens, thousands, 10,000, 100,000. So this would be what? 10,000. We have 400,000s and 3 sets of millions. All right, number 5. Using the numbers 9, 2, and 6. So here we have our 9, or 2, and 6. It says, what is the smallest number you can make with 6 in the tens place? All right, and for options, they give us the following options. A, they say 2, 9, 6. So this is automatically out, because they say 6 needs to be in the tens place. All right, so we have 9, 6, 2. So 6 is in the tens place, but this is a number that's even larger than the one that we got originally, because this is 926 and this is 962, so it's even larger. So that's out. Then we have 269 and finally 629. So we have to have tens in the sixth place. So this one is out. So we are only left with what? With 269. So 6 of the options that we were given, and using the process of elimination, we're able to conclude that 269 is the smallest number of these numbers given that has 6 in the tens place. Alright, so this one cannot be used because 9 is in the tens place. This one cannot be used because 2 is in the tens place. 962 is even larger than the number that we were given to begin with, and 269 is the smallest number there. So before we go, let's remember that we have face value, place value, and true value. So in the number 296 here, 296, let's take the 6 for example. The face value of the digit here is 6, so this would, let's say that's 6, and then the place value is 1, and then to arrive at the true value we multiply 6 by 1 and we would get 6. So that's the true value of this digit here. Let's think of the 9. The face value is 9, the place value is 10, so 9 times 10 would give us what? 90. Then for this one, the face value is 2, the place value is 100, and 2 times the 100 would give us 200. All right, so looking at it, if you were just to look at a grade 1 child and say which one of these you think has the greatest value, which one would you want more than not? The child would say, I would want the 9. But even though the 9 face value is larger than the 2 actually has a greater what? Value than 9, because this represents 200 while this only represents 90. So always remember face value, place value, and true value. All right, so let's move on a little bit now. And it says number 6, we have 924, and we're to look at that in exponential form. All right, so here we have 924, and if we were to break this out, expanded, then we would have 900 plus 20 plus 4. All right, so 900 plus 20 plus 4. In order to better understand this, we know that 9 times a set of 100 would give us the 900, right? We know that 2 sets of 10 would give us the 20, and 4 times 1 would give us the 4. Let's look at exponents over here. So 10 to the 0 power is 1, 10 to the first power is 10, 10 to the second power is 100, 10 to the third power is 1,000, 10 to the fourth power is 10,000, 10 to the fifth power is 100,000, and 10 to the sixth power is 1,000,000. All right, the rule is 10 to the 0, always 1. So any number, whatsoever the number is, once we see that number to the 0 power, it's 1. 10 to the first power will be 10. It represents the exponent, tells you the number of times that number is supposed to be multiplied. So we only have one set here. So this is just so 10. However, 10 squared really means 10 times 10. And if we work that out, we would get 100. But if we notice, we have 2 zeros here. So this and this works only for 10. So this little 2 shows the number of zeros we need to have in powers of 10. Look at this again. So 10 to the third power, 10 times 10 times 10, or 10 cubed, really would be what? 100 times 10. And if we have 10 $100 bills, we know that that's $1,000, right? Again, we have 3 zeros. So the exponent here, right? Because if we have 10 and we have squared, this number is called the base, right? And this one is the power or the exponent, right? So the exponent tells us the number of times it should be multiplied. So again here, this one, after working it out, shortcut, we see that we need to have what? 3 zeros there. So 10 to the fourth, again, 4 zeros. 10 to the fifth, 5 zeros. 10 to the sixth, 6 zeros. So I hope we're following that. So let's look now back at what we have. So this would really be 9 times, what's 100? This would be 10 to the second power, or 10 square, plus 2 times what? 10. So 10 would be what? 10 to the what? First power, plus 4 times 10 to the 0 power. All right, and we could bracket these off, make them nice and neat as best as we can. So if we were to put 924 in exponential form, what we should have would be 9 times 10 squared plus 2 times 10 to the first power plus 4 times 10 to the 0 power. Why? Because 9 times 10 squared is the same as saying 9 times 100. And here we have the 900. And 2 times 10 to the first is the same as saying 2 times 10, which is 20. Here we have the 20. And 4 times 10 to the 0 power is the same as saying 4 times 1, which is 4. And when we put all of that together, we get 924. Next one, number 7, says that we should write the answer for this. It says write 7 times 10 to the 5th. 7 times 10 to the 5th plus 5 times 10 to the 4th plus 2 times 10 to the 3rd plus 9 times 10 to the 1st. So here we would have what? This would be 7 times 100,000, because that's 10 to the 5th. Remember that 10 to the 6th is a million, so this is 100,000. 10 to the 4th, 10,000. 5 times 10 to the 4th, right, is 5 times 10,000. 2 times 10 to the 3rd is 2 times 1,000. And 9 times 10 to the 1st is the same as 9 times 10. Let's go with this then. So this is really 700,000. Let's write this. 700,000 plus 50,000 plus 2 times 1,000 is what again? Oh, yes, 2,000 plus 9 times 10 is 90. So if we were to add all of this together, we would get 752,090. All right, so let's put our separators here. So our answer should be 752,090. All right. Let's go to the next one. The next one, number 8. Which of the following is a set? And they have here, I'm sorry that this is so small, the collection of multiples of 6, comb, river, hand, deck, cherry, Nisberry, pumpkin, Jerry, Susan, Chase, Latoya. Now I just went to this website, mathisfun.com, to look for the definition of a set. What is a set? Well, simply put, it's a collection. Firstly, we specify a common property And pay attention to this that says the what common property among things, right? So in order for us to really define them as a set, they need to have something in common, right? So it is just things grouped together with a certain property in common. Now, I don't know based on Jerry, Susan, Chase, and Latoya what they have in common. Nisberry, I don't know what these have in common, right? But definitely, I can see here that A, the collection of multiples of 6, all of these have something in common to show that they are actually multiples of 6. So the multiples of 6 would be like what? 6 times 1 is 6, 6 2 is 12, 6 3 is 18. You know, all of those things would show what? Some relationship to 6, right? So all of these things have something in common. So that's why I would go with A as our answer. All right. So now for number 9, it says if set A is equal to 3, 5, 7, and 9, and set B is equal to 2, 4, 6, 8, and 10, set C is equal to 12, 14, 18, 20, and 24. And the members of set D would be 21, 26, 31, and 36. What is the union of C and D? What's the union of C and D? Now, when we're looking at union, what we're going to do, we're going to include all the elements of the two sets without any overlap. So we don't write the same thing twice. So let's put this in. So we have 12. We would have 12. We would have 12 there. Then we have 14. Let's see. We have 18. We see 20. From set D, we see the next one would be 21. Then we see 24 in C. Yes. Then go back, we see 26. Then 31. Hold on. 31. And finally 36. Let's double check this. So we should have 12, 14, 18, 20, 21, 24, 26, 31, and 36. All right, cool. Let's now go to the next item, which says which of the following is an infinite set? And in order to answer that, we need to be able to define a finite and an infinite set. And a finite set would have what? Members that are countable, and an infinite set would have members that we can't count. It makes no practical sense to try to count these members. So let's go. We have the number of students enrolled at a school that we can count. For example, some schools have a population of 2,500, 1,500. Some schools might have a population of 50 students. Right, so we can count them. All we have to do, get all the registers in the school and look at the number on roll, add those together, and we would get the total population or the enrollment for the school. Spectators at a football match. Yes, we could determine the spectators at a football match because we could use the tickets that they present. We could count the tickets presented, or we could count them as they go through the gate one by one to get the exact number that are in the stadium or at the match. All the factors of 100. Now this, all the factors of 100, yes, we could actually determine the factors of 100 because, and let us use the method here. So if we have 100, the factors of 100 would be 1, and let's close with 100 there. The next one would be 2. 2 could go in there 50 times, right? 3 can't go in there, but 4 can go in there. 4 can go in there 25 times. 5 could go in there 10 times. 6, 7, no more. So we have closed it. 1 could go into 100 times. 2 can go in there 50 times. 4 can go in there 25 times. 5 can go in there 10 times. And the reverse is also true. 100 can go into 101 times. 50 can go into 102 times. 25 can go in there 4 times. And 10 can go in there 5 times. So it is possible for us to list all the factors of 100. But the last one here, the last option D, says all the multiples of 10. All the multiples of 10. Now, this could go on until Jesus comes back. So, in terms of finite versus infinite, the last one here that says all the multiples of 10, that one could go on forever. So, we would say that set is the infinite set. So we have a Venn diagram here. It says use the Venn diagram to answer questions 11 to 13. It shows the number of students in a class who take music and art. So here we have music, we have art, and the number of students. So 11, how many students take both music and art? So we're looking for the area of overlap or the intersection. And in this case, the intersection is 5. So we could say 5 students take both music and art. How many students take neither music nor art classes? And I would say that it would be 3. And why 3? Because when we look here, we see that music, art, and we have some that are in this universal set here outside of the specified categories of music and art. So we would say 3. How many students take music classes? So if this is music, I'm looking for the entire circle that represents music. So I have 8 and 5. So 8 and 5. 8 plus the 5, and this would give me 13. So 13 students would take music by themselves. All right. Let's go on now to number 14. Number 14 says, the length of a square field is 75 meters. Tremaine walked around the field twice. What is the distance that he walked? 150 meters, 300 meters, 600 meters, or 75 meters? All right, so square, what do we know about a square? We know that all sides are equal. So if this is one side and he's supposed to walk around the field twice, out of those answers, automatically I know that the last one cannot make any sense because he could not walk around the entire field and only walk 75 meters when that would be in fact one side of the field. All right, let me write the options here so you can follow. So answer A is 150 meters, right? B would be 300 meters, C 600 meters, and 75 meters. So this question wants us now to look at perimeter, because perimeter is the total distance around the shape. So this would be 75, and then you'd walk another 75 there, another 75 meters here, right, and 75 meters here. So this is really what? 75 times 4, and that will give me how much he would cover going around it once. So let me get this. So 5 4s would be 20, right? The 0, carry 2, 5, not 5, 4 7s would be 28, 28 and 2 would be 30. So this is 300. So walking around it once would be a total of 300 meters, but he went around twice, so it would be 300 times 2, so this would be 600 meters in all. So my answer, if this is A, B, and C, my answer would be C, 600 meters. So in this question, they're really trying to test our knowledge of perimeter. To say Tremaine walked around this field twice, the distance covered would be what? 600 meters. All right, this next question has a shape that looks like this, and it's asking us to tell what the perimeter of this shape is. And here I have some measurements here. I have 6, I have 4, 1, 7, and I'm going to be missing one side because I have one side here, I have another side here at 7, 6, 1, but I'm missing something here. I need to fill in what's there. How would I know what to put here? All right, so from here to here, all of this is 7. From here to here, this is 1. All right, so now I would need to find right here and right here as well. So if this is all the way as 6 and I have 4 here already, then this side really should be what? This should be 2. From here to here is 2, because the 2 and the 4, that would make the total length of the top. So this really should be 2 units there. And if all of this is 7 and I have 1 out of it up to this point, it means that this is 6. All right. So now that we have found all of these, then we could say we have 4 plus 7 plus 6 plus 1 plus 2 plus 6. All right, so 4, 7, 6, 1, 2, and 6. So 4 and 6 is 11. 11 and 6 would make 17. 17 and 1 would be 18. 18 and 2, this would be 20. 20 plus 6, and this would give me 26. So my answer there should be 26 units. All right, so the perimeter should be 26 units, whatever the units are. Now we go to this question that is perimeter based, but they give us the perimeter and then ask us based on the information provided to tell what the width is. So here's the question as stated. The perimeter of a rectangle is 89 centimeters. If the length is 32 centimeters, what is the measurement of the width? Now, again, we have to understand the basic rule for perimeter, the total distance around the shape. So if this is 32, and we have to understand that this is a rectangle, so the two long sides are going to be equal. So this would be 32 centimeters as well. And then we don't know what is here. We don't know what is here. All right. So what do we know? We know that the total is 89. And then we know that 32 and 32, that would give us the 64. So 32 and 32, we add these together and we get 64. So if we take the sum of the long sides from the perimeter, that's the 64, then what we would have the sum of the short sides. All right, so let me just make this a little neater here. Take this one out. All right, good. All right, good. So let's 4. Let's work with this now. 4 from 9 would leave me with 5, and then 6 from 8 would leave me with 2. So it means that between the short sides we have 25 centimeters, right? So because they are supposed to be the same length, because that's one of the properties of the rectangle, then this would be divided by 2. So it would be what? 25, and we're going to divide this by 2. Now 2 into 2 goes 1 times 2 ones would give us 2. We're going to subtract, we have 0. We're going to bring down. Now 2 into 5 goes 2 times. 2 2's would give us 4. Subtract, bring down 1. Now 2 into 1 can't work, so I'm going to add my decimal point there and add 0 to continue. And 2 into 10, that goes 5 times. 5 2's would give us 10, and we are done, no remainder. So this means that the measure of the width, one side, one piece of it, would be what? 12.5 centimeters, or 12.5 centimeters. All right. Next question, number 17. The scale of drawing to the actual object is 1 centimeter to 15 meters. If the length of the drawing is 5 centimeters, what is the length of the object? All right. So the approach I'm going to use is that of a ratio. So we have, what we know is that 1 centimeter really means 15 meters. And they say we have 5 centimeters on our drawing. So what is the length in the real world? So what I would do, I would simply cross multiply, find the cross products. So remember that numerator names the side. So this really would be x times 1. This is x. So the unknown would be equal to whatever 5 times 15 is. So x would be equal to whatever 5 times 15 is. Let's make our x a little bit neater here. Good. And we can just put this aside, and we say 15 times 5, and 5 5s will be 25. We write. Okay, so if we have 25 like this, we're going to write 5. We're going to carry 2 5 1s, 5 and 2. So this should be 75. All right, let's see if this is true. So 1 centimeter to 15 meters, and now we have 5 centimeters, and we want to know if that is 75 meters. To test it, we are going to see if the cross products are equal. So 1 times this should give us what? 75 on the left hand side, and then 15 times the 5, which we just work out, is 75 on that side. So we know that our what ratios are equal. Once we get this statement, it means that this is true. So it means that 5 centimeters on the map, or whatever the drawing is, really represents 75 meters in real life. Time for number 18. Number 18 says, what is the distance on a map between 2 towns if the actual distance is 25 kilometers and the scale is 1 centimeter to 10 kilometers? So here we have 2 towns, and I like to say to you guys, if you draw it up, create a little mock-up or a little drawing or something, it helps you to better understand it. So here I have town A, and this is town B, and the distance between them is 25 kilometers. We know that. And they give us the scale. So 1 centimeter to 10 kilometers. Now we need to find out what it is that the x represents there. So we are being asked to find x, which is the actual distance on the map. So if the ratio was 1 centimeter to 10 kilometers, then we need to find what's the distance on the map, because they told us what the distance is in the real world already. So I'm going to go with cross multiplication, and I would have 25 on this side, right, being equal to 10 times x. And remember, x is just 1. This is 10x. I would divide this side by 10, and for balance, I'd have to divide the other side by 10 as well. So 10 will cancel 10 here, leaving with x on this side. And now 10 into the 25 would go 2.5 times. All right, so if you want us to show that, 25, we're going to divide by 10. Okay, so 2 can go into that. 2 tens would give us 20. This is not the right sign, so this would leave me with 5. No, 5. 10 can't go into 5. We'd have to add our decimal point, add 0 to continue, and 10 into 50 goes 5 times. 5 tens would be 50, and we are done here. So my answer would be 2.5. Now we need to test this or check our answer to see if it is correct. So 1 centimeter to 10 kilometers should be the same as 2.5 centimeters to 25 what? 25 kilometers. All right. Look at this. They multiply this by 10 in order to get here. So this increases tenfold. So if we increase this tenfold, we should get that as well. The cross products will help us as well. On this left hand side, we would have 25. The cross product here is 25 because 1 times 25 is 25, and 10 times 2.5, that's also 25. And we know that once we get it to this, then we are correct. So our final answer is that on the map, 2.5 centimeters would represent the actual distance of 25 kilometers if the ratio is, or on the scale, it's a scale of 1 centimeter to 10 kilometers. Our last question asked us, which of the nets is a triangular pyramid? Now, remember, a pyramid has a point at the top, and the base would be triangular. So this is the one that best suits it. The one that they have looks like this, where we have a large triangle with another in there that would create 1, 2, 3, 4 different triangles. 1, 2, 3, 4 different triangles inside. So this one is the one that represents a triangular pyramid. So when you take it, lift all the sides, it has triangular faces with a triangular base. Alright guys, this is the end of our little review on mathematics. I hope that you will find it useful. Please remember, use your textbooks, revise as best as is possible, and I'll see you in the next episode.